Hello and welcome back to Fireside Math Chats with Mr. Collier. Hope everybody's been doing okay. Even without having classrooms and all of that business to spend your time with, I wanted you to know that you can still get your math here. And today we're going to talk about solving trigonometric equations, which is pretty fun for me, maybe not for you. It really depends on the person. But trigonometric equations are cool because you get to use all of the algebraic rules you already know. You're just going to work in trigonometry with it. So let me check and make sure that I'm lined up okay. Looks like that's pretty good. And let's try this out. Okay. So this is a trigonometric equation. It's different than a proof because we no longer are saying to prove that this thing is equal to this. We want to know when this thing is equal to this. So we're looking for the x value that makes this statement true. Well, if this was 2x equals -1, all you would do, let's look at this first problem, if x equals -1. If it was 2x equals -1, all you do is divide by 2. So we do the same thing here, and we get cosine of x equals -1/2. And this, we've seen before. This is a value from our unit circle. If we think about the unit circle, and we think about what would make our cosine value, which is our x value, be -1/2, there would actually be two places in between 0 and 2 pi where this would occur. It would occur up here at 2 pi over 3, and it would occur down here at 4 pi over 3. Now, technically, there are infinite solutions because after 2 pi over 3 and 4 pi over 3, you could go around again, and you'd end up at 8 pi over 3. And you could keep on going for forever and ever and ever. But often in math books, you'll see something like put solutions so that everything fits into 0 is less than or equal to x is less than or equal to 2 pi, or 0 is less than or equal to x, which is less than or equal to 360 degrees. If you see this, your answer should be in radians. If you see this, your answer should be in degrees. But regardless, if I see something that looks like either one of these, I know that I'm only restricting myself to a certain set of solutions. And in this case, my solutions would be 2 pi over 3 and 4 pi over 3. If I wanted to move to the next problem, which is slightly trickier, we have 4 sine squared of x equals 1, which I think people recognize based on the problem before. We would start by turning this into the sine squared of x equals 1/4. Well, now we're going to take a square root, which means that the sine of x is going to equal positive or negative 1/2. And so now, if we think about our unit circle, we're interested in places where our y value is they're equal to positive 1/2 or to -1/2. And since we're looking for y values, we're going to find solutions here, 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 and here, which means that we can get 4 solutions between 0 and 2 pi for this particular problem. And our answers would be at pi over 6, 5 pi over 6, 7 pi over 6, and at 11 pi over 6. Hopefully, this is all following with what you all know about solving equations from before. Now, let's look at one that continues to get a little bit trickier. This last one, 2 cosine squared of x equals 1 minus cosine of x. And let's start by talking about some things that people might try to do. These would be things that would not work well. I'm going to get a different colored marker. So one thing that I see people do is they say, well, I don't like that there's a cosine squared, so I'm going to divide everything by cosine. So 2 things to watch out for there. If you divide by cosine, you potentially eliminate solutions. So dividing by a variable is something that we really want to try to avoid doing when we're solving an equation, because if anything would make cosine x equals 0, and if that was one of your solutions, then you're not going to get that solution to show up. So generally, dividing by variables is bad. And if people try to do that, you would divide by cosine of x, you divide by cosine of x, and you divide by cosine of x, and you'd end up looking at 2 cosine of x equals 1 over cosine is secant of x minus 1. I don't know that that necessarily makes the problem look any easier. So be careful what you wish for if you try to divide things by cosine. Another thing I'm going to see people do is take the square root just because they're scared of this exponent on the left-hand side. That just creates all kinds of problems over on the right-hand side. I wouldn't go down that rabbit hole. What you can do instead is set this up so that everything is equal to 0. So we could have 2 cosine squared of x plus cosine of x minus 1 equals 0. And this looks sort of familiar. In fact, if instead we had something that looked like this, 2a squared plus a minus 1 equals 0, and I asked you how to solve this, you would probably say either factor or use the quadratic formula. And you'd be right. So we're going to factor this thing. I'm going to give you a brief overview of how I like to factor. I call it tic-tac-toe factoring. It was taught to me by Brad St. Germain about 15 years ago in Houston. So what I do is I take my first term, I take my last term, and I multiply those across. I take these two numbers, and I need numbers that multiply to make negative 2 and add to make 1. And so if they multiply to make negative 2 and add to make 1, I'm going to have positive 2a and negative 1a, and over here I have 2a and a. 2a multiplied by 1 and a multiplied by negative 1, and my factors are on my diagonal. So I end up with, remember a was cosine of x plus 1 multiplied by 2 cosine of x minus 1. And then the question becomes, remember, this is what we were trying to solve. What makes this true? Well, this would be true if cosine of x equaled negative 1. And that's going to happen over on the left-hand side of the unit circle, which is at pi. And here, we're really saying that cosine of x would be equal to 1/2. And that's going to happen in 2 different places on a unit circle. That's going to happen at pi over 3 and at 5 pi over 3. So in this situation, we end up with 3 solutions. So we had 2 solutions here, 4 solutions here, 3 solutions here. Don't just expect that this is a situation where you're going to have one solution. Solving trig equations, because you're dealing with things that are on the unit circle, you can have multiple things give you values that you're looking for. So that's a breakdown of solving basic trigonometric equations. In my next video, I'm going to get into some trigonometric equations that are a little bit more complicated. So stay tuned. Hope you all are having a good day, and I'll talk to you soon.